So we're talking about Chapter 9, and in Chapter 9 we're going to learn about inferring population means. The whole of Chapter 9 is just two main topics: applying the central limit theorem for sample means, and then making inferences about population means using confidence intervals and hypothesis tests. That's all we're going to do in this chapter. Lots of parts to it. So the objectives for this chapter, the outcomes: sample means of random samples. We're going to discuss accuracy and precision of the sample mean as an estimate of the population mean, and find the standard error with the distribution, sampling distribution of the sample mean. Now, I just wanted to make sure that we are clear about some of the definitions. Three characteristics of the sample mean. Okay, accuracy, precision, and probability distribution. This is these three parameters have been discussed previously, and we're just going them over in more detail at this point. Okay, the notation again: the letter mu is the population mean, x bar is the sample mean, sigma is the population standard deviation, and s is the sample standard deviation. So again, sample is x and s, and population is mu and sigma. Okay, notice the Greek letters are used for population, and normal letters are used for samples. The accuracy and the precision of the sample mean. The sample mean is unbiased when estimating the population mean. On average, the sample mean is the same as the population mean. Okay. Now, the precision of the sample means depends on the variability in the population. The more observations we collect, the more precise the sample mean becomes. Okay, so the number of observations is directly proportional to the precision of the sampling mean. The sampling distribution can be thought of as the distribution of all possible sample means that results from drawing repeated samples of a certain size from the population. Here is a reminder, very important reminder: the standard deviation of the sampling distribution is called the standard error. So when we're referring to the sampling distribution, we don't say standard deviation, we say standard error. Now, effect of sample size on sampling distribution. As the sample size increases, the standard error decreases. The mean remains the same. Okay, so that mean will go unchanged. If in this case the mean is 90, okay, as we increase the sample size, the standard error decreases. You can see the curves becoming smaller. So there's fewer errors as the sample size gets larger. That curve is narrower in that sense. All right, now here's an example. A student has a large digital music library. The mean length of the songs is 258 seconds with a standard deviation of 87 seconds. Okay, that's the whole population. The student creates a playlist that consists of 30 randomly selected songs. Is the mean value of 258 seconds a parameter or a statistic? Explain. The mean value of 258 seconds is a parameter because this is the mean of the population, all of the songs in the library. What song should the student expect the average song length to be? What should the student expect the average song length to be for his playlist? Okay, so here we go. To answer this, the student should expect that the average song length of the playlist is what's given, 258 seconds, because the sample mean is typically the same as the population mean. Part C, what is the standard error of the length of 30 selected songs? Notice we're using standard error here and not standard deviation because we're talking about the sample. So there's a formula that is used for standard error. It is sigma divided by the square root of n, where in this case, the sigma value, 87, is given in the problem, standard deviation 87, okay, divided by the square root of the sample size to give 15.88. That is the standard error. Now, the last question is asking us, what would a playlist of 50 songs have a standard error that is greater than or less than your answer, part C? So if you increase the sample size, think about what happens. If the playlist had 50 songs, the standard error would become smaller because the standard error decreases as the sample size increases. In other words, that number would be lower than 15.88. It would be now 87 over square root of 50, which if you put that into a calculator, let me put that into my calculator, would become 87 divided by square root of 50 to give approximately 12.30. That standard error would become smaller as the sample size increases. It increases from 30 to 50. And this is what happens. Okay. Right, I'm gonna just pause this for a little bit and fix something here. So if we were to consider some of the problems for chapter 9.1, I'm going to deal with chapters 9.2 separately from chapter 9.1. A study of all students, this is the homework for 9.1, okay? Remember, the homework are combined, so the first 8 questions are from 9.1. A study of all students at a small college showed that a mean age of 20.8 and a standard deviation of 1.3. Are these numbers statistics or parameters? So because this refers to all students, we're talking about the population. So they are the numbers for parameters because they're for all the students, not a sample. And remember that for population, we use the Greek letters. So mu would be the mean, and standard deviation would be sigma. Next question is a survey of 100 random full-time students at a large university showed the mean of the number of the semester units that were enrolled were 13.8 and the standard deviation of a 2.2. So now we have a sample, a survey of 100 students taken from the large population of students. So clearly this number is a statistic. The number is a statistics because they are for the sample, not all the students. And remember, for statistics, we use for the mean, we use X bar. So this is our X bar here. And for the standard error, which they refer to as standard deviation, we use the regular letter S. All right, now let's check our understanding of this. The distribution of scores of a certain exam, okay, is N 70 and which is the mean is 70 and the standard deviation is 5. Which means that the exam scores are normally distributed with a mean and a standard deviation of 5. Sketch the curve and the label on the x-axis, the position of the mean plus or minus 1 standard deviation, the mean plus or minus 2 standard deviations, and the mean plus or minus 3 standard deviations. So we're looking for a graph, first of all, that has the mean, the middle part, as 70, which we can see that we have two choices here. Both of these have the mean as 70. Now we're looking to see which one actually goes backwards by 5 spaces and forward by 5 spaces. And we can see right here that this is our graph. Okay, 70 plus 5 is 1 standard deviation, then 2 standard deviation, and 3 standard deviation. 70 plus 5 is 75, 75 plus 5 is 80, 2 standard deviation, and then 70 plus 3 standard deviations is 85. Same backwards, 70 minus 65, 70 minus 5 is 65, 65 minus 65 is 60, and 65 minus 15 is 55, 3 standard deviations. Okay, now what is the probability that a randomly selected score will be less than 65? So we're looking for a graph that shows a shading to the left of 65 right there. Shading to the left of 65 because it's less than 65. If you're not sure, you can use the StatCrunch program, but I don't really know that it's necessary. Remember how you do this? Stat, calculators, normal, and you would type in your mean and standard deviation. Let's get our I don't like this here. I can't see it. Okay, here we go. Trying to get the numbers in place here. This is not helpful. All right, so the mean is given as 70. I'm going to have to keep shutting this down. Okay, mean is given as 70. And the standard deviation is given as 5. And then they're asking us for less than or equal to 65. Okay. And compute. Okay. And there you can see the graph that we're looking for. And I don't know, really, it's really not really necessary to use a calculator, but just in case you wanted to check your answer, you can. Okay. All right, moving right along. Question 4. Given n 40 and 45, 40 and 5, which is a mean of 40 and a standard deviation of 5. So we're looking for a graph which has the mean is 40 and then plus or minus 5 points in each direction, which is graph C in this case. Okay, 40 plus 5 plus 5 plus 5 to get to 1 to 2 to 3 standard deviations. Now, question continues, what is the probability that a random selected score will be between 30 and 50? So in between immediately gives you a clue here. This is between two standard deviations, to the left and to the right. Okay, now if you wanted to again put this into your calculator, 40, let me write my numbers down here. 40 and 5 is the mean and standard deviation, and we're looking for in between 30 and 50. So you would go to the StatCrunch program. I'm just going to simply edit this or delete it and start over. Yeah, so stat calculators normal, we want a mean of 40 okay, standard deviation of 5, in between, so between 30 and 50. Compute, and you can see the graph there between 30 and 50. Copy the image, place it in the notes, we're good to go. Okay. And really, there's no need to use StatCrunch for this. You can actually infer the answer based on what's given. All right, let's go ahead and look at the rest of the problems. The average income in a state was 70,000 per person per year. Suppose the standard deviation is 1900 and the distribution is right skewed. Suppose we take a sample of 100 residents of the state. Complete the parts below. What values should you expect for the sample mean? Because the sample should be representative of the mean. If it is unbiased, then we would say that the sample mean should be still 70,000, same as the population mean. Okay, and that is because the sample mean is unbiased, an unbiased estimator of the population mean. What is the standard error of the sample mean? So remember a formula for this. Standard error is equal to, go back here and get that formula, sigma divided by the sample size. Yeah, so sigma divided by the sample size. Sigma divided by the square root of the sample size. So the standard deviation sigma is 19,000, sorry, divided by the sample size is the square root of 100, which is 19,000 divided by 10, which is equal to 1900. Okay, so 1900. N is equal to 100. and sigma is equal to 19,000. So standard error is given by that little formula right there. All right, moving on. A useful estimator for the population mean is, anybody want to guess? Estimator from the notes is the sample size. The spread of the distribution of the sample mean is much smaller than, much smaller than, much smaller than the spread of the population, okay? Because the sample, and remember, the larger the sample mean, the less spread out it will be. Which comes to question 8. As the sample size is increased, the spread of the sample means decreases, which is this one. Okay.